Welcome back to lesson 2.3. Today we're going to look at taking quantitative and qualitative data and looking at measures of location. And the first measure of location that we're going to look at is going to be called percentiles. And sometimes we'll call them quartiles, but those are special percentiles. Percentiles by definition are, we use the symbol P of K, where K is the percent of the data that falls below P. Okay, we're gonna do some so you can see what it looks like. We're also gonna look at the median. The median is a number that measures the center of the data. You can think of the median as the middle value, but it does not actually have to be one of the observed values. It is a number that separates ordered data into halves. Half the values are the same number or smaller than the median, and half the values are the same number or larger. So we would order the values from smallest to largest, and then we're looking to find that middle. If there are an odd number of data values, then the very middle number is the median. If there are an even number of data values, then the average of the two middle values is the median. But we're going to use Desmos to calculate that for us. So quartiles are special percentiles. They are numbers that separate the data into quarters. Quartiles may or may not be part of the data. Q1 is how we're going to write that symbolically, is 25% of the data is below this value. Q2 is the median, and that's where 50% is above and 50% is below. And we are going to reference Q1. We'll reference the median. I rarely will say Q2. I'll just say median. And then Q3 is where 75% of the data is below this value. The interquartile range is a number that indicates the spread of the middle half or the middle 50% of the data. It is the difference between the third quartile, Q3, and the first quartile, Q1. So it's calculated like this. IQR is calculated by taking the Q3 minus the Q1. So to decide if we have any outliers, we talked about outliers in our frequency chart in 2.2, lesson 2.2, as well as in our histogram. And to calculate them numerically, if you want to find out numerically, if we're using the median to represent our center, then the outlier is going to be a number that's below a lower fence or any of our data values that are above the upper fence. Okay, and to calculate the lower and the upper fence, notice that they're similar formulas, but the lower fence uses Q1 as the base number, and then we're going to subtract 1.5 times the value of the IQR. The upper fence is going to be starting at the base value of the Q3 plus 1.5 times the value of the IQR. Okay, again, an outlier using the lower and upper fence is any data point in our data set that is either below the lower fence or above the upper fence. The IQR can help to determine potential outliers. A value is suspected to be a potential outlier, and we kind of spell it out here again, below the lower fence or above the upper fence. So let's look at an actual example here with these. So it says, for the following 13 real estate prices, calculate the IQR and determine if any prices are potential outliers. And here are the prices of homes that we're going to look at. And so it says, order the data from smallest to largest, which we have. And then M is our median. It's 48,800. So since there's 13, which is odd, that means that we have 6 on the left and 6 on the right, and the 13th one is the middle, it's the median. So we can actually go 1, 2, 3, 4, 5, 6, and then, oh, sorry, so in the smallest to largest, 1, 2, 3, 4, 5, 6. So this one is our median, and then we would have 1, 2, 3, 4, 5, 6 on the right. So this is our median. We note that with an M. And then to calculate our Q1, so our Q1 is by taking the average of every data value that is below the median. So our Q1 is by taking the two middle values. So 1, 2, 3, 4, 5, 6. So that means we're going to take the average of the two middle values in the everything below the median. So these two right here. And we get this. And then the Q3 is taking the average of the two middle ones in above the median right here. Now, Desmos is going to calculate this for us. Okay, so I'm going to show you how to calculate this. Actually, the next data set we'll do in Desmos. I already have that in for you. So once we know the median, the Q1 and the Q3, we can calculate the IQR. So the IQR is the Q3 value minus the Q1. So this is our IQR. And then if we want to take 1.5 times the IQR, we get this value here, 510,375. Our lower fence is taking Q1 and subtracting that. So we get a negative value. And then our upper fence is taking Q3 and adding that 510,375, and we get our upper fence. So you'll notice that our lower fence is a negative value, and that's okay. It's just we know realistically we're not going to have a house price that's less than $0. So we're not going to have any house prices, home prices that are lower than the lower fence, and that's okay. It is okay to have a negative lower fence. Now, our upper fence is $1,159,375. So since we have one house that was $5,500,000 is above our upper fence, then we do have a potential outlier. So that's something to recognize. So let's go ahead and we're going to start learning how to calculate these in Desmos. So the first one we're going to try together says, for the following 11 salaries, calculate the 5-number summary, IQR, then determine if any salaries are outliers by using the upper and lower fences. Okay, so because we have 11 salaries, that means the one in the middle is going to be our median, and they're not labeled smallest to largest here. But if you go into the modules and click on the Desmos link for this lesson, you will see that I have the data in here for this example. So I've listed the data here, and then to find basically what's called your 5-number summary is everything we need for helping us find our upper and lower fence. So if you type stats and then a parenthesis and type in your data set. Now mine is X1, so I'm typing in X1. After you've entered a few data sets, your next data set might come up X3. Just make sure that you're noting which data set you're using. And then hit enter, and it gives you the min, the Q1, the median, the Q3, and the max. And it also gives you this box plot here because you can see my, actually my data is in blue. Yep. So the box plot that's showing you on the screen, I just want to make sure that it's showing this one here. So we don't need that to show yet. Okay. So right now for this first example, we just need the min, the Q1, the median, the Q3, and the max. So I'm just going to write in my paper the Q1 is equal to 40,500. The median is equal to 54,000, and the Q3 is equal to 69,000. Now, I've done some calculations here for us in Desmos. So our IQR is the Q3 minus Q1, and I took those and subtracted, and there is our difference. Our IQR is 28,500. And then our lower fence is going to be taking our Q1, subtracting 1.5 times our IQR. So our lower fence is a negative 2250. And we're not going to have a salary that's that low. So we know we don't have any below the lower fence. And our upper fence that we calculated here in Desmos is 111,750. And we do have one salary that is higher than that, 111,750. So we do have this person here. So 120,000 is greater than the upper fence, which was 111,750. So we have a potential outlier. So I mentioned the 5-number summary. It's the min, the Q1, the median, the Q3, and the max. We're not going to actually look at it until lesson 2.4, but I like to bring it up just because it's what pops up when we use stats in Desmos. So okay, the next example says, find again the Q1, Q2, Q3. Remember, this is our median, Q2, and IQR. Then determine if any test scores are outliers by using the upper and lower fences. We have test scores for class A and test scores for class B, and they are in Desmos. So let's just go ahead and find that. And remember, on my paper here, I'm going to jot things down from Desmos just so I can compare once I get here. So I've got class A and class B, and I'm going to look for my lower and my upper fence, my lower and my upper, and then I will decide at the end if I have any data values that are potential outliers. So let's go ahead and go to our Desmos here. So the Desmos here is listed. I have data in X2 and Y2. So my class A scores are in X2 and my class B are in Y2. You can see them listed there. And then, so I found my 5-number summary for stats for my X2. And then I found my IQR. And then that's my R for, oops. If I want to type something, I have to go up here and tell it, make sure I type in notes. So this is my IQR for class A. And then it's 18. And then I'm going to do the same here. And there's my IQR for class B. It's 21. And so for A, the Q1 was 72.5 and the Q3 was 90.5. So I am finding my upper and lower fence for class A. The lower is 45.5 and the upper is 117.5. So how about I just note these for you here. Oops. Upper, actually this is the lower fence. Okay, so that's the lower fence for class A. And then that's going to be the lower upper fence. For class A. And then class B upper and lower down here. So the lower for class B was 41 and the upper for class B is 125. And we can see that I'm gonna go back to my paper here for a minute. So we can see that we didn't have anybody score lower. And you know what, the cool thing is you can look at the min and the max. The min and the max will tell you if you have anybody that falls above or below those fences. So if we go up here, the min does not fall lower for each, and the max does not fall above for each. So there doesn't appear to be any outliers for this data set, for either of these data sets. Okay. So sometimes we're given a data set and we want to find a particular percentile. Now I showed you how to find, the 25 percentile, the 50th and the 75th. But we're going to learn how to find any percentile that we're looking for. So it says if you were to do a little research, you would find several formulas for calculating the kth percentile. This is the one we're going to use. So if I want the kth percentile, it may or may not be part of the data. I is the index of what I'm going to use here, ranking or position of a data value. So the first, second, third, fourth, or fifth. And it's the total number of data. So order the data from smallest to largest, and then calculate I by taking your kth percentile divided by 100 times n plus 1. If I is an integer, then kth percentile is the data value in the ith position in that ordered data set. If I is not an integer, then round up, round up I up and round I down to the nearest integers. Average the two data values in these two positions in the ordered data set. This is easier to understand in an example. So let's do that. So we have listed our 29 ages for Academy Award winning best actors in order from smallest to largest. Find the 70th percentile. So K is 70 and N is 29 because we have 29 data values. So we're going to take, this should have been 70 divided by 100 times 29 plus 1. And so this, you can see, I'll show you quickly on my phone here, that 70 divided by 1 is 0.7 times 30, and that comes out to be 21. So the 21st, because it's an integer, we can actually use the 21st. The 21 is an integer, and the data value in the 21st position in the ordered data set is 64. So the 70th percentile is 64 years. That means that 70% of the data is below 64 years old. 70% of the data of these 29 Academy Award winning best actors is younger than 64 years. So now we're going to try one on our own. It says listed our 29 ages for Academy Award winning best actors in order. Again, from smallest to largest. So these are the same actors, but this time we're going to find the 20th percentile and the 55th. So the same data. So K is equal to 20. N is still equal to 29. So I, for this one, is going to be 20 over 100 times 29 plus 1 equals, I can do this again here. So 20 divided by 100 is 0.2 times 30, which comes out to be 6. So we're going to count 1, 2, 3, 4, 5, 6. So 27 is in the 6th position. So we can say that 20% of the 29 actors are younger than 27 years. That's what that tells us. Then they wanted us to find the 55th percentile. So that's 55 now is K. So I, in this case, is going to be 55 divided by 100 times 29 plus 1, which is 30. So 55 divided by 100 times 30 is 16.5. So we have to average the 16th and the 17th values. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 52 and 55. So that means we are going to add 52 plus 55 and divide by 2. So 53.5. Now, it's not an actually one of our data values. Okay, so we would now say here, so we would say and we can, let's write this out. So we can say that 55% of the 29 actors are younger than 53 and a half years old. That's what that says. Okay, the last thing we're going to learn how to find is finding the percentile of a value. So this time, if we take an actual value in our data set, we want to find out what percent is below that data value. This is, I think, a little bit kind of easier to find actually, but it says order the data from smallest to largest. X is the number of data values counting from the bottom of the data list up to, but not including the data value for which you want to find the percentile. Y is the number of data values equal to the data value for which you want to find the percentile. N is the total number of data. So it would be X plus 0.5 Y divided by N times 100, then round to the nearest integer. So percentile indicates the relative standing of a data value when data are sorted into numerical order from smallest to largest. Percentages of data values are less than or equal to the pth percentile. So for example, 15% of data values are less than or equal to the 15th percentile. Okay, so let's look at an example. We're going to go back to those 29 Academy Award winning best actors from smallest to largest, and it says find the percentile for 58. So this is the percentile we're finding for 58 right here. All of these, what percent are all these below 58? So counting from the bottom of the list, there are 18 data values less than 58. So X is 18. There is one value of 58. So we're going to multiply that times 0.5, 1 times 0.5, and divide by 29. So we would say 18 plus 0.5 divided by 29, and we would get 63.8. And so we're going to round up because that's a natural rounding. So 58 is a 64th percentile. So let's try a couple on our own. So I want to make sure. It says I have 30, but I'm thinking maybe I typed that wrong. There's really only 29, 30, 30. So I think maybe 1, 2, 3. Well, I do have 30. So I guess I have to go back and see, there's an additional one here in this day. Oh, we have 2 31s, that's why. Okay, a little bit different than before. Find the percentiles for 47 and 31. So 47, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 below. So X is equal to 15, and there's only one of the 47s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so our calculation is going to be 15 plus 0.5 times 1 divided by 30 this time, times 100. So we have 15 plus 0.5 divided by 30 times 100 is 51.7. So we're going to round up to 52. So 47 is the 52nd percentile. There's 52% of the data that's below 47. And then 31, we added one to the list so that we would have a little bit different, to jazz up the calculation here. So 31 says 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 below 31. And then this time there's 2 data values at 31. So we have to multiply 0.5 times 2 divided by 30 times 100. So let's see here. So that's 8 plus 1, because 0.5 times 2 is 1. So 9 divided by 30 is 0.3 times 100 is 30%. Okay. So 31 is the 30th percentile. Excellent. Next our last two questions here. It says for the 100-meter dash, the third quartile Q3 for times for finishing the race was 11.5 seconds. Interpret the third quartile in context of the situation. So third quartile is 75%. So 75% of those running the 100-meter dash were faster, right? Because they were less than, were faster than 11.5 seconds. And the last question says, during a season, the 40th percentile for points scored per player in a game is 8. Interpret the 40th percentile in the context of the situation. So 40% of the players scored fewer than 8 points. So that wraps up lesson 2-3. It's all about percentiles, different percentiles, how to find an outlier using the IQR. And this lesson was all about when our center is at the median, when the center is at the median. So catch me back for lesson 2.4.